Hi students, welcome back into today's video where we are continuing our discussion in the variation. By the previous video, follow the link down here. You should be in the position to follow what we have been doing. We have already started looking at one type and we're done with that. And as such, in the same video, you were able to see that we have also introduced into the second type of variation, that's the inverse. So today, what we are going to do in this video is an issue of trying to have some kind of practical problems that we're going to solve that are pertaining to issues about the inverse variation. Right now, before we get into the discussion about the inverse variation through problems, can we just have a recap of what we need to know about the two types of variations, right? Because what matters most is there you students have to at least be able to recognize that, say, the problem is talking about which type of variation, and when you are solving, should be able to be guided by such rules. Right, so just to remind you up and make it a summary and very brief about the first two variations that we have already discussed. That's the direct and the inverse. You should be in the position to at least differentiate the two types of variations. Like the most issue that is needed here is the issue about the proportionality equation. How do you compose a proportionality equation for the direct variation, and how do you compose talk of the proportionality equation of the inverse variation? Right now, based on all what we have been discussing, you should be in the position to summarize everything and be able to conclude that everything about the direct variation and the inverse variation has to go by the format of the equation as such. Like, say, for example, if we may be told that, say, two quantities, like, say, talk of a T and M are varying with each other, you should be in the position to say T and M can vary directly, T and M can vary what? Inversely. So if it is issue about the direct variation, based on what we have discussed, the statement that you can bring when T varies directly as M, it should be T varies directly as M. That is about direct variation. And now the equation of which that you can use to work out the value of T and M, the one we described as the proportionality equation, should be described as T is equal to a constant times one variable, which is M. So this is just a statement describing the relationship between two terms, which is T and M in the direct variation, while this one is the kind of the proportionality equation that you'll be able to use to work out the value of a quantity T and quantity M, while K is always your constant. Right. But now when it comes to the inverse, the same. If we say T varies inversely as M, then the story changes a little bit. Based on the practical example we had, we cannot present our statement in this way when we're talking about the inverse, where one quantity increases, the other decreases. In this case, from what we discussed, it means now the statement will no longer be T varies like M, but now you're going to present it this way. T varies as 1 over M. So you can see here, this is about direct, this is about inverse. And then now the proportionality equation that can be yielded from this statement about the inverse should be equal to something like this, that T is equal to a constant on top of M, and here your M comes like a denominator. So when you try to compare the two proportionality equations, this is for the inverse, this one is for the direct. This is the statement for the direct, this is the statement for the inverse, and that's the way it should be in this topic. Right, let's also see what is it about the other remaining two variations. That's the joint and partial. Right, and this is what is crucial. The equations are not all that necessary. The thing is to know exactly what is it that we are supposed to know in the variation as such. Now, the time being, we have a problem here. Of course, we just have two on the problems. Right, we can't have several. We may be able to consult several textbooks, or so many questions about the variations you'll be able to solve. But in my case, I just give you only two examples are enough. Right, let's see what is it about the inverse now. Are the processes of solving the same or maybe different? You will be able to realize, as far as we talk of the changes of the quantities, I don't expect that the problem should be different. But the approach itself in terms of proportionality equation, that matters most. Right, so here we have a problem about the inverse variation, the number of beats per minute of a pendulum, still in physics, right, varies inversely at the square root of its length. Right, the moment you hear inversely, just know that there's a variation in the way these quantities vary. If one would be increasing, it means the other decreases. If the other is decreasing, it means the other one increases. Right, so we are told that an 81 centimeter long pendulum makes 24 beats per minute. Those who are taking physics, I think they're already there, they know what a pendulum is, and all the statement about the length here, they know, and we'll talk of the beats, we are able to know what this one is. Right, 81 centimeter long pendulum makes 24 beats per minute. Right, now we're asked to calculate the number of beats per minute of a 25 centimeter long pendulum. Right, to say that if length decreases of a pendulum, what happens to the number of beats? That's what is here. 81 centimeter long pendulum give you 24 beats. What about now a 25 centimeter long pendulum? Right, so a good example of inverse. Here's the way we go. Right, so here how identify the two quantities which are varying, right? First, so you'll be able to talk of the issue here or lies on the number of beats versus the length. So you can say, let the beats be represented by letter B, right? But now the beats here, we are really targeting what? The number. So sometimes you may not use the letter B if you don't mind. You can just use maybe the letter N. I say we are looking at the beats, but in this case, we're looking at the number of beats. That's our interest. So you can have, let's say, number of beats be represented by capital what? N. But the choice of the variable is not an issue. You can choose as well as you're able to define what variable that one is. So our N here represents the number of what? Beats per minute. And then length is the one that is varying with the number of beats. So the quantity beats there, number of beats there is in relation with the length. So you'd also say let length be represented by any variable of your choice. In this case, I'll choose error. So our discussion is there focused on N versus error. Right. Now, if the two, N and error, are varying inversely, how do we present such statement? So by what I've just introduced, you'll be able to see that in this case, when we say number of beats of a pendulum varies inversely as the square root of its length, then the statement will come something like this. Number of beats varies inversely. It means 1 over what? Now here we're told is that we are told about the nature of the length. Here we're told that it should be a square root of the length. So instead of just writing error here, I'll now take the square root of which? That's now square root of error. So in this case, it means N varies inversely as the square root of a length. That's what it means there. First statement, number of bits, which in this case is N, varies inversely as the square root of the length. This is 1 over root of error. Right, that's how it goes. If it was direct, I would have just written it as say number of bits varies directly as the square root of the length. That's the difference. Right. Now, out of this, I will need to come up with the proportionality equation that will help me to work out the value of N at instance when error is known, or find the value of error when N is known. Right. Now the proportionality equation comes in as N is equal to a constant on top. Down here, you have got the square root of error and be in the position to describe the meaning of K. So here you'd say where K is constant. Like that. That's how it goes. Right? So please follow what I'm doing. When I bring the where this is coming from, what about this one? Where is this one? Like that. A statement, here you have got an equation used to wake up the value of n given L or the value of L given n. That's the way it goes. Now, it's crucial always to, first of all, come up with the constant of the proportionality. What is the constant value that is guiding the relationship between n and L? So you are there, first of all, to do that. Calculate the value of k. So k will always be found whenever you know the quantity L, at the same time, you know the value of n, when n and L are compared. So in this case, we are told that, say, if we talk of the 81 centimeter long pendulum, the number of beats to be made per minute is 24. So here you say, when talk of n is equal to 24, you talk over what? And the talk of the, let's say, L being equal to 81. That is the instance when we can yield up the what? The constant. How come we know n and then we know L? It means there must be a constant of proportionality that is there weighing the two quantities, that is n and L. So how do we yield that constant out? So what we do, we are going to capitalize on the given what? Statement up here, which is an equation, proportionality equation. So we're going to substitute for n with 24. So instead of writing n here, we're going to write 24. And this is equal to our k as such, we leave it intact. Then here we take the square root of L, which in this case is the square root of what? 81. That's the way it goes. Right. Then now to wake up the value of k, you can do a simple mathematics there. Firstly, find the value of the square root of 81 and then get rid of the fraction that you have there. Right? So I'll go up again. From this stage, we have our 24 is equal to k. The square root of 81 is 9. So here you have got your 9. So to find the value of k in this case, you just have to multiply both sides by the denominator in this case, which is a 9. Right? So here it means I have to multiply 24 by 9, and this side again I have by k over 9 times 9, like that. So if here I multiply 24 by 9, what I'll get here is 216. Because I've got 9 times 4, 36, 9 times 2, 18, plus 3 is 21. Here you just have to divide 9 into 9 is 1, and that one should be multiplied by k, you get k. So which means k is equal to 216. Right, so the constant of proportionality in this game is 216. Right, so as usual, as what we have been doing in the direct variation, the next chapter is to come up with the complete proportionality equation. Right, the one which was described up there, was it complete? Now it must be complete. Right, so what do you do here? You're going now to rewrite the proportionality equation like this. So you come here and say, therefore, proportionality equation will be described as follows. So you have it as the talk of the n number of bits is it what? 216 divided by the square root of what? L. That is our proportionality what? Equation. You see? Just easy. Some processes were carried out in direct that also handled in inverse variation. What differs is only the statement you bring to summarize the presentations in the question, and then the issue about the what? Proportionality equation. Right, what next? Our question here is there pertaining to the number of bits. We are asked to wake up the number of bits of a pendulum for the pendulum which is 25 centimeters long. Right, what is the number of bits for a 25 centimeter long pendulum? So by what we have been doing in the direct variation, you know well how to handle that part. So what we do here, it's more like you are asked to work out the value of n when L is 25. Right. So how do you do this? You come and present your light up like this to say this 25 we are given here. That one is n. So you'd say now when n is equal to 25, then now you're going to take your proportionality equation and have it there. You use it to work up the value of what? N. Right. So my proportionality equation here is described as n is equal to 216 over root of error. Right. Right. Not here, not n, but now here I have to talk of error. This is the length. It's not n. Given that 25 centimeter long pendulum, what are the number of bits? So please can make the correlation there to say when error is 25, what would be the number of bits? So here we are there going to calculate the value of n instead of error. Right. So now what are we going to do then? Here is simple. You are already there. I have all hope that what we need to do here, we just have to substitute for error. So it means wherever I see error, I need to write 25. So here what I'll have, my n is equal to 216 over square root of what? 25. Right. So the value that I'll get from this stage will be like n is equal to 216 divided by square root of 25 is equal to a 5. So here I'll write a 5. And when we divide that 5 into 216, our n turns out to be, that is 43.2 bits. Right, so that's the number of bits. So those who take physics, they know what it means by 43.2 bits in this case. So it means 1 bit is not complete. That's why I've got a decimal number in that way. Right, so that's the way we do in the variation, more especially when we're talking about the inverse. Let us have just the last example. As I said, I cannot give you lots of the example because the processes means almost like the same. Let's finish with one more example, then we cover issues about the inverse. Right? So you should be now in the position to apply the knowledge of the variation we're doing in here, even other sectors of knowledge. Thus, like for example, we're talking about physics. Look at the problems we're having here. It's more like we are handling issues about physics. What do you have here now? If you are here, I've just left you this problem to try it and have to mark. But for formality's sake, since we are learning, let us see, learn and have skills of such. Right, now, what is it that we have? We are told the force of attraction, F newtons, between two bodies varies inversely at the square now of the distance d meters between them. If the force is 860 newtons, when the distance is 50 meters, we are asked to calculate the force of attraction when distance is 200 meters. And the distance when the force of attraction is 350 newtons. A realistic example. You have learned more about physics. So here, let us see, use the knowledge of the variation to calculate the distance and also calculate the force of attraction. Right. So what we're going to do here is nothing different from what we have already done up here. So we're going to take the same approach, right, in order to come up with the solution for the two problems. Right? So here we are. Solution. Force of attraction is represented by capital letter F. This one is in relation with the distance, which is d. So how is the relation like? We are told that the force is inversely proportional to the what? Distance. So the statement has to be indicated here. and you write here to say false varies inversely as the what? Square of the distance. Right, so in this case, it means we're going to present it like f varies as the square of d, like that. Then next, you have to come up with the equation of proportionality, where the two quantities are compared. So that equation comes in by what we have indicated that area. It will be like this one should be 1 over, that's the d squared. It will be equal to f is equal to, on top there as numerator should be k, and down here should be what? D squared, like that. You see what we have here? Right, f varies inversely as the square of d. Right, so now once you have written your statement of the talk of the proportionality equation in this manner, tell us something about k. So because k is not described in this question, so do you know that every relationship that is there between or amongst quantities, they must be constant. So always do not forget to include the constant. We have had already the example that gives issues about the constant. Constant must be there each time you are working out issues about the what? Values of the quantities. So statement f is equal to 1 over d squared tells us that f is varying inversely as the square of a d. And here now this is a proportionality equation. And here you indicate, say, where what? My k is constant. Right. So that's it. You can see there's not much difference with the previous example that we have had. Now, if I would like now to continue working on this one, the next thing that we're going to do here is just a matter of calculating the value of k. Right. The first thing, work out on the constant. So to find the constant, get to know the states of f and the state of d at the same time. What is the value of f and the d will be what at that particular instance. Then be able to know the value of what? A k. So here we are told that say when d is equal to 50, right? It is found that say f is 860 newtons. So just like when f is 860 newtons, d comes in as 50 newtons meters, right? So with the two, you can be able to use them in order to calculate the value of what? A k. Right, so what I'll do here, I'll just explain a little bit, because this problem I see is more like the one who have already done it. So I'll leave it to you to finalize everything, because it's just like a repetition of what we've done. It'll be your exercise. Right, so what do you do here? You just have to substitute. Here for f, you write your 800 and what? 60. That is the newtons, that's the force, is equal to what? Your k divided by d squared. Your d squared in this case is what? 50. So you write 50 squared, like that. Then what do? This is just a simple arithmetic. Just simplify this part. 50 squared is just like 50 times 50. Right, so you go on like 860 is equal to k over 50 times 50, you get that's 2510, sorry, 2 zeros, like that. So that is the value of what? Of 50 squared. Then after, what do you do here? In order to find the value of k, you do the same as we've done earlier. You need to have to get rid of that fraction. How do you do it? Multiply both sides by the denominator of this fraction, which is 250 in this case. So what is it that we're going to do? You multiply here by 12. That's the talk of the 2,500. Here again, also multiply by what? 2,500. And you're going to find the value of what? K. Your k is the value here. Let's take that k is what? A in this case. But you can do the simplification there. Right. So what I want you to do is this, that you have to utilize what we have been doing in the previous example and what I've just started up to continue working out the solution to the two problems. Calculate the force of the traction when D is 200 and also the distance. Find the distance. That is, now you just have to calculate the value of D when F is 350 newtons. Right. So here, just to give you a guide, please, what you do here is just a matter of using the calculator. I know you have it there. Do the tabulations. Continue from this stage. Calculate the value of K. What is K? So A here is representing the value of K that you are going to use from this stage. Once you have found the value of A, which is the value of the constant, in this case, write down your proportionality equation as we have had, as we have already done in the previous example. Once you have introduced that, then do as we have done. Calculate the value of the force. In that case, it will be just the value of F. When D is 200. And then what else? You're going also to substitute for F. In due course, then you're going to wake up the value of what? AD. So just have to substitute here when it comes for the first one, force of attraction. When D is this, it means you're just going to write 200 squared and then find F. The same if you want to find D, in this case, it means F has to be substituted here and you're going to calculate what? The value of D. While in due course, you know the value of K, which you are going to obtain from this stage. Right, so my dear learners, this is mathematics. Can you just finalize this one? It's not just an issue where I have to listen. But rather, thank you very much. I have all hope that you know now something about the inverse variation and you're able to differentiate with the issues about the direct variation. So please keep on revising so that you keep updated and be able to analyze the issues about the variation. Next, we are to be fed up with the another type of variation. This is joint. The very last, it will be partial, then our topic is over. Right. Thank you very much, and let's meet again in the next one, category of the video. Thank you.